So
Folks, I tried to, I mean, it is on like Donkey Kong today, tomorrow, and Wednesday, folks. As soon as everybody takes the quiz, I can hand those back and you can look at them. You do need to go back and fix them for yourself, not for me. Yes. Yeah, you need to. Now, you tripping if you don't go back and look at what you got wrong. Because here we go. That young man. More continuity. Here we go. I'm not sure how much of this we have already done.
We got through that problem and that was
this slide and that was it. Okay, today's the 10th.
So I don't think we can do things with number one.
I don't think so. We're going to go on. We're going to roll on with this. This is still part of section 2.4. A continuity, folks, you should know what infinite continuity is. You should know what to look for. Point, discontinuity, jump, what's the other one I'm missing? Removable. You need to know what it looks like from a graphic standpoint. You need to know what it looks like from an algebraic standpoint and what happens to functions when you have removable discontinuity, okay? That's what was assessed on Friday with that quiz. Where are these functions not continuous? What's the big picture? What is this really asking for?
Find this kind of whatever. That's how.
And you know what? That cosine is not even supposed to. Yeah, it is. Doesn't even matter. What is it asking for? Where are the following functions not continuous? If a function is not continuous, then it has to be what? It has to be undefined, okay? Where is f of x? Undefined.
So you have to make sure.
Okay, so if the function is undefined, then what?
There's a zero in the denominator.
There has to be a zero in the denominator. So in order for me to find those values, then it's right in there. How wrong? What am I going to do with this denominator? I'm going to set the denominator equal to 0. And then we're going to solve like normal, correct?
Yes.
Okay. It's a quadratic, so we set it equal to 0, we factor it. What is it? 3 and 2. Are my signs the same or different?
Different.
Which one's going to be minus?
3.
Okay. And then, of course, we get two solutions, which would be x is equal to 3 and -2. You guys agree with me there?
Yes.
Now go back and look at what it was asking for.
Where is it undefined there?
Where are the following functions not continuous? Well, it's not going to be continuous when x equals 3 and x equals -2. Do you guys agree?
Yes.
Okay, f of x is not continuous when. Do you agree with me? Yes or no? Okay, write this down. We've already done this one, but you better get ready. Okay.
Been ready.
Been ready? Okay, we're ready then?
Ready.
Let's move on.
This new. Ooh. Oh.
You cool?
Yeah, it's right here. No, paper off.
Okay, gotcha. Look at this one.
Oh, go back to the mall.
Look at that.
It is totally fine because what are we looking for?
Just where it's not.
So what do I do?
Set the bottom equal to
You
0.
set the denominator equal to 0. That is exactly what you do. And we're not going to freak. We're not going to run and scream and throw our hands in the air because we're frightened.
I think I know
that.
we have to lock those e's so that it cancels out, so the e's cancel out.
Well, not
You gotta
yet.
get that one
But
on
what
the
did
side.
Get that one on the other side. Hold that
So
thought.
add one.
So we're going to add 1 to both sides, and I get e to the x is equal to 1. Now, Lauren, you know I got to do something. How am I going to get that x down on a normal level, not as an exponent?
Log this e.
I have a log base e. What I do to one side, I have to do the other. Is it okay for me to write log base e of e to the x equals log base e of 1?
Sure enough.
What's the other way it's okay for me to write?
Go ahead, cancel that.
Natural log.
Oh,
Okay, I'm on natural log both sides because that is just shorter to write. Natural log of e to the x is equal to natural log of 1. What I do to one side, I have to do to the other, correct?
Hey,
Now, what happens on the left side?
And natural log of 10 as well.
The ln and the e both cancel out because of the property. Remember those properties. Which is going to leave us with what on the left side?
X.
Plain old x.
Um,
And then we are left with the natural log of 1. But wait, there's more.
For real.
What's natural log of 1?
0.
What's our little way rule?
The identity.
Lane load.
Oh.
Leave.
The natural log of 1 is 0. When x is 0, when x equals 0, what happens?
It's not continuous.
Doesn't equal 0 power is 1. Anything 0 power.
When you plug it back in.
Yeah.
I got you, okay. So when x is 0, f of x is what? What are we trying to do? We're trying to find where the function is not continuous. So the function is not continuous when x is 0. When x is 0, f of x is not continuous. Right on? Now let me ask you something. What have we not looked at?
The top.
We've not even looked at the numerator. Is that okay?
Yeah.
Are we answering what we're supposed to be answering?
Yes.
Yeah. We just kind of disregard it. It just happens to be there. Okay? We can find a lot of other stuff out about that function, but we don't have to. Okay? Fossil or difficile? Fossil. Finding the undefined values, very easy. Denominator. What's that all go back to?
I don't understand.
When we find these places, these things, these values that make a function not continuous, what's that all go back to? Well, we set our denominator equal to 0. What's that all go back to?
0.
No.
I don't understand.
But what does that go back to?
That's what we've been doing.
It goes back to the graph.
I don't understand. Miss Perry, can you be more specific? Yeah.
Well, I'm just
More
trying to
Pacific, please.
More specific.
be more specific.
Algebra.
What about algebra?
Algebra.
You said it took us to graphs, right?
He did make.
Calm down.
I said algebra. That's
Calm
fine.
down.
Okay.
You said graphs, right? When we first started this class, what did I graphed you to death. And I said, tell me the blank and blank of that function. The domain and range. Does this not take us back to domain?
It does.
Sure it does, because how do you find the domain of a rational function? You set the denominator equal to 0. It's all about the x values, which are your domain values.
We were all like, what?
I'll get it out of you eventually. Okay. What about this one? It all goes back to what? It all goes back to domain. So we have to find what's legal for our x values, what fits in our domain, and what doesn't fit in our domain, right? How do you find where this is not going to be defined? It all ties back to domain.
You still got that domain. Never mind.
It does, but we can't really do
Can't
anything
set
with
1
it.
equals 0.
Can't set 1 equals 0.
What do you?
Let me ask you something. What kind of function is this?
Logarithm.
It's a logarithmic function. Now, before we got here, and I didn't even intend for this to happen, but I kept pulling and pulling and pulling, and I finally got PJ to say it all goes back to what? Domain and range. All right, think. Logarithmic functions, domain. How would we have found the domain of this function?
Find the acid from the verb class. On the x, you have to find the constraints of where it starts and where it ends. You know.
Would you do
It's
x
got
values
that-
yourself?
It will have a vertical asymptote,
Yes.
but how do I find that where the legal x values are? There's something we always did.
I mean.
Well, what do I
I
do?
apologize.
X minus. You do
Do what? Don't have to worry about
I know,
that.
we know that x minus 3, so you're going to translate the graph right through. And then it's everything x is greater than 3. Well, x is greater than 3.
Shut your face. Say it again.
Which part?
You just did your work out loud.
Wow, that's what I was saying.
Okay. That's what you did all your work out loud.
Okay.
You said that, I know,
You know-
say it again.
You're gonna translate the graph right through because x minus 3 is inside the parentheses.
That's right.
It's x values, and then your vertical asymptote is gonna be a 3. And so you know everything. X is greater than 3 because there's asymptote.
He's thinking graphically. But I always told you guys if we were finding domain algebraically, what did you always have to do with the expression?
Greater than 0.
That's what I was, yes, you got us there. That's what I'm looking for. Take the expression, the stuff. We did this big time. And we have to set it greater than 0, okay? So we got x minus 3 is greater than 0, and then x is greater than how much?
3.
So I guess, KJ, that the vertical asymptote is there. Isn't it great to be right? You know you're right. It's good. The vertical asymptote is x is equal to 3. Okay, 1, 2, 3. It would look something like this. And it's going to roll over. That's what a log function does.
Do you want to graph it?
No, I don't. But I'm putting it here. You can include it, but I will never ask you to graph it. For your notes, it's okay. Now, what did my instructions ask for? Where is it not continuous? Let me ask it this way. Will the function be continuous when x is greater than 3?
So x is less than or equal to 3.
What does this mean, x is greater than 3?
Everything on the right side of 3.
That means that the function itself, every point on that graph, every point on that curve will be greater than 3, correct? All right, now, where is this function not continuous? When it's less than or equal to 3, okay? If all of the values are going to be to the right, you said it, but we can't just let you, we all got to get that.
All of us, everybody.
The function's going to be on the right side of that vertical asymptote. So where is it not continuous?
Less than.
X is equal to 3 or x is less than 3, correct? If it's not even over there, well, then it's not continuous over there. F of x is not continuous at x equals 3 or x is less than 3. Do you agree, yes or no? Does that make sense?
Is that, what kind of discontinuity is that? Is there a name for it?
Looking at the picture, I would assume that it would be what kind? I would assume that it would be infinite. However, could I ask you to find the limit of that function as x approaches 3? Why not? Would it exist?
No.
Would it exist from the left?
No.
I can't even get over there, can I? There's nothing over here. Can I find it from the right? No, because then it's just going where? To where? Negative infinity. So if I can't even get there from the left, it's going to negative infinity from the right. Will a limit exist?
No.
Which means it's going to be discontinuous somewhere, right? And by looking at this graph, if you see an asymptote, what do you assume that it's going to be? Infinite discontinuity, okay?
For the exception.
Probably. And we're going to run into them as we come to them. I do not know right off the top of my head what they would be, okay? But when we get there, that's when we send a sweet little email and go, please help me, okay?
Like, I think it's okay.
That's what you got to do. That's what you got to do. What do you think?
I think it's easy.
It's not so bad, right?
At all.
Okay. Let's look at something else. Now, I don't know what you need to do for this. I tried to, the internet kind of threw things off with my printer. I was going to have this printed off. I don't know that you even need to write this thing, okay? Just look at it. I'm allowing you not to take notes and just sit back and chill and pay attention and chill. G of X is continuous on what intervals? It's continuous on what intervals? What kind of function is G of X?
G of X is all that or just the top label?
G of X is everything on that graph.
Okay.
What kind of function is that?
It's a,
Is it a quadratic?
nah,
No.
it's not, that's just continuity, not kind of function.
Sorry.
But good. It's got a whole lot of discontinuity, doesn't it? What kind of function is it?
Just a regular function, that's all it is. It doesn't have a name. It's not, can't categorize. Can't categorize that.
Yes, you can.
It's unique.
How come?
It's,
I can categorize
oh,
that.
there's a word for it.
Yes?
It's a,
Come on, man.
it's, step,
Step function looks like steps.
it's a name for it.
What is it? It's a
Piecewise.
piecewise function. It's got a whole bunch of junk going on there, right? This is a piecewise function, okay? Now, where is this function continuous? Meaning, where does it not have holes? Where does it not have gaps? Where does it not have asymptotes? Okay? What we're going to do is we're going to read this from left to right.
Oh, definitely.
You have done this in algebra, okay? In algebra 2, you did this. Now, if I'm reading this graph from left to right, am I going to be thinking about my x values or my y values? Do we agree with x values? Okay, so I'm paying attention to my x values. Now, what are we going to do? Left, right. Like I just transition right back. Where's this graph curve coming from?
Negative infinity.
Negative infinity. Okay. So it is coming from negative infinity to where?
0.
Where does it look like it's approaching? Do we agree that it's probably approaching 0?
Yeah.
That there's probably a what on that y-axis? It's probably an asymptote. Okay? You can't even see it. Right there. You know it. There we go. So, negative infinity to 0. Where's the next continuous piece?
Don't forget that union there.
I'm not even going to really worry about the unit.
Oh.
I just want us to list the intervals.
Oh, okay. Well, from 0, well, are we doing the brackets and parentheses?
We are doing the brackets and the parentheses, yes.
Okay. So it's from 0 always positive.
Oh, hold on. But I'm looking at each piece.
Oh, okay.
Each piece. This is this piece. What's this piece right here?
0.
Where's it starting? The x value is 0, correct? Is it going to touch that 0? No. So is it going to be a parentheses or a square bracket? It'll be a parentheses. So it's going from 0. What's this? Parentheses at what value? 3. You guys agree with that? Yeah? Because I'm looking at each piece of the function. Where is it continuous? It's continuous from negative infinity to 0. Right here. No holes, no gaps. No asymptotes, right?
No, holes, gaps, right?
That's right. Here to here. From 0.
But when it stops right there, wouldn't that be a closed bracket?
No, it's not included.
Oh.
So remember, only if it's included do we get the square brackets. Okay? 0 to 3, do you agree with that one? Yes? Why did we have a parentheses on the beside 3?
What you just said.
But why? Because it's a hole there. It's not included. All right, so what about from this next piece right here? Closed to closed, what number to what number? 3 to 5. Closed to closed, 3 to 5. And then pick up that next piece, parentheses or closed?
Yeah,
Parentheses 5 to where? Infinity with a parentheses, because infinity always gets parentheses, right? Did I say it right?
No, I didn't say it.
Oh, okay.
I said parentheses.
I thought you said.
What do you think? Is that weird?
Nah.
kind of weird, but do you understand continuity, yes or no?
Yeah.
I can tell you do because your responses are just so confident.
It's just pointing out like where they are.
That is what it is. Just
Been
pointing
doing
out the
that since
X's.
algebra.
Okay? Are we good?
Yes.
We good with this? All right, moving on. Look at this, continuous on the open intervals. You do need to copy this down. Let me give you a moment. Make sure you have all that. You gotta have the picture. It's gotta be included in your notes. These are the best math notes in calculus ever. This one is one of those theorems that we can't get away from. And this should make total sense to you.
Nonsense.
If there is a y value, and we'll call that y value f of m,
Oh, changing it up.
between f of a, the y value for a, and f of b, the y value for b, then there is at least one x value m between those x values a and b. I mean, that's just common sense to me. Exactly. Write the theorem. If it has quotation marks around it, you know that's a parodyism, right? That is not what the book is gonna. The book is gonna be very technical, way more technical.
Things like
But in my head, that's what makes sense to me.
things like the calculus are dumbest books that they issue to all schools. Like these. Innovative right here.
Say what?
I don't know. I don't know what I'm saying.
No. Say that again. I gotta.
Calculus for dummies like math, because they have all those crazy definitions. Nobody understands what they're saying.
Right.
It's not doing any good to the people, like, well, I guess except for the people that take the initiative and want to read the book. It's not really doing good to the common person that wants to. You recording me too?
I'm recording.
Well,
I
I'm
like this
sorry.
conversation.
It's not good to the common person that doesn't really want to take the time to understand those. They want simple answers. They give them simple answers.
Right.
Going around
That's what we need to know.
without talking around in circles and telling them everything that the nice
Is
to
that
knows.
talking around in circles?
I mean, no, I'm talking about the books. They need to tell them the need to knows before they tell them nice to knows.
Need the nose before the not to knows.
It's nice to know.
Nice to knows. It's too many noses. I get you, KJ.
Well, I still have to explain them with the need to knows. But she, what's he on?
No, he's
Oh.
it's still recording, isn't it?
Okay.
It is. It's okay.
That's
Do
okay.
you have that picture drawn too?
No, no.
Because if the picture doesn't, I'm sorry, we have a bird in here.
Kevin.
Kevin the bird from the Up movie. Moving Up. I'm glad he's safe in our room.
Is this just
Right.
3 at the bottom?
It is A, M, and B. But you have to get the graph. If the graph, we'll not show you how to do this problem.
Mom,
That's a lie. I'm going to show you how to do this problem. Look what it has to do. We got to prove the intermediate value theorem. Always trying to get back to the problems, right?
Hey.
Okay. So, we know that if A has a corresponding Y value, f of A, and if B has a corresponding Y value, f of B, then whatever point in the middle of A and B, there should be a corresponding middle point, correct? Okay, all we're doing is finding order pairs. So we're going to think of -1 as A, and we're going to think of 3 as B. Now what do you think we're going to do? Based on that graph from the last slide, what do you think we're going to do?
Point of what point?
Say it again, Lauren.
What point?
No,
Alphabet.
no.
Oh, I can do that word.
Plug in A. And then going to plug in what? B. So let's do that. Let's find f of -1. We're going to plug in our A value to find the corresponding Y value. Please don't get this wrong. What is -1 to the third power?
-1.
-1. It's -1, isn't it? -1 times -1 is +1. +1 times -1 is -1. What's -1 plus 2?
1.
1. So, the corresponding Y value for A is -1. F of -1 is 1, correct? Now, Lauren, we're going to do what you said in just a minute. Okay, we're gonna go back and grab this in just a second. Now, what's step number 2? Plug in the 3. So f of b, f of 3, 3 cubed plus 2. PJ, would you say 3 cubed is what? 27 plus 2 is? Right on. So I've got my b value, and I have my f of b value. Yes? Yes.
Right.
Okay, all right. Lauren, what did you say earlier? Plot points. All right, so we got negative 1. 1. That one's easy. And then b is 3. 29, something way, way up here.
Right.
Okay? What kind of function is this?
Looks like it's about to be like that. I'm thinking.
No?
No, it's not. It's about to be an exponential.
How do you know it's a cubic function?
I'm guessing.
Because it's an x cubed function, right? That has been translated up, down, left, or right to. It's been translated up to. So there's, what do I call this function? That's a John Travolta curve, isn't it?
Yep.
Okay, so will it have arrows on the ends?
Yep.
Will it?
I know.
Why not? Because it's got
Oh.
brackets, so there will be
Constraints.
no arrows. It is literally going to start at the point on the left, and it'll have some little curve, something like that, won't it?
It'll intersect it too, though, won't it?
We're sketching,
Okay.
right? But yes, it would go up and cross through the y-axis at 2. Now, I've got to prove the intermediate value theorem. Okay, so here's negative 1, and here's positive 3. How am I going to prove that there is indeed a value m?
It's kind of just because.
No, it's not just because. That's
Prove it,
not a
just
good
leave.
proof. No, that is not a valid reason. Folks, what are the x values in between negative 1 and 3? 0, 1, and 2. Can I just choose any value in between negative 1 and 3? Yeah, I can. Okay. So, choose any value. Any value, 0, positive 1, positive 2. Could I choose a fraction?
If you want to.
Sure. I wanted to. Why do I not want to?
It's not an integer. It's not
Because
gonna
it's
work.
not an integer. It's not going to. I'm not using a calculator, so I want something easy. What would be easy?
1.
So you said 1.
If you want to.
Okay, we'll choose 1 because Jeff said so. And what am I plugging into?
The original function.
What's it going to be?
3.
See, right?
Yes.
Yeah. So is there a point
There is.
in between A and M and B? And we chose 1.
That's 2.
I bet that point right there would be 1, 3. If I checked it on the calculator. Do you think? It would have to be. Okay, so that is this is my M. This is my F of M. Correct? And that just follows straight from the theorem. What do you think?
Tell me that they're intermediate
It's the
values.
intermediate value theorem, the IVT. Okay? The intermediate value theorem.
We haven't done motivation or anything?
We just motivated ourselves.
We have not.
Yes, La la la, you get better. La la la, I can't hear
No
you.
more.
How old are you? Here we go. So infinite limits. I want you to think about this function. Write this down. Go ahead. Go ahead. Write this down.
Let's go and do a plan.
I'm sorry.
Right.
Yeah, he's crazy.
That's disgusting.
Who is?
Yeah.
Yes.
What's this case?
That.
Yeah.
Yup. No. Right here.
I'm about to go.
Infinite limits.
Hey, Jane. Have you looked over this stuff for her?
I
Think
looked
about
at
the
it
function
badly.
f of x is equal to 1 over s. It's like, look how much, look at those straight notes you got.
she say?
That's
What
what
was
it's
the
called.
way?
Think about the function. That's equal 1 over x.
I need like a little.
What? The limit as x approaches 0 from the left. What is that function? 1 over x.
How much it?
What is the function 1 over x? What is it? So it's a reciprocal function. So isn't it here and here? That's the reciprocal function. Write this down, please.
Then,
So, if I'm approaching 0 from the left, from the
One
left,
question, when it's negative 1 over 8, it's like this way, right? All right.
will be reflected about the x-axis. Now, when it's approaching 0 from the left, where is that curve going? Where is it literally? Say again? Isn't it going this way to negative infinity, y'all?
It's an X infinity.
Actually, for this, it is approaching negative infinity, okay? We'll talk about that in just a minute. This is when we're dealing with infinite limits, okay? What's going to happen, though, when x is approaching 0 from the right? It's going towards positive infinity, okay? Now, if I told you to find the limit of as x approaches 0, what would you tell me? It does not exist. Because our fingers don't meet, right? So what kind of discontinuity does this function have? Infinite. Where is the asymptote? It's x equals 0, which is the y-axis. You guys have to know that. You must know that, okay? Now, a limit where f of x increases or decreases without bound as x approaches some number is an infinite limit. Doesn't matter what x approaches. It can approach 3. It can approach negative 41. But if it is approaching without bound to negative or positive infinity, then you have an infinite limit. This is where things change a little bit. Okay?
why?
All ready? Put your phone up. Now, I know, y'all catch every time. We're ready? I feel like you know, but all I say this name last name. Look at this one. Do I have paper?
Here.
No, You can share some sheets of paper with her.
I'm going to get some.
You can tear them out.
I'll get it back.
Oh, there you go. Thank you. We have to find the limit as x approaches 0 of 1 over x squared.
No, why don't you laugh?
Is that building
Maybe? Not in the first and third anymore. I feel like the only time I'm referring to a calculator. I don't want to have to write that out on paper, okay? But I do want to look at this. And you can just look at it here. That's up to you. Was it 1 over x squared? I was in the trick. Look at that picture. Okay? Do you see where they're both approaching where? Positive infinity. Okay, it's going up like this and up like that. Right on? Now, here's the thing. we have to look at the limit as it approaches from the left. How do I denote that it's the limit as x approaches from the left?
It doesn't have a script.
The superscript of what? Not if it's from the left. It has to have the minus sign of 1 over x squared. Where is it approaching from the left, y'all? Everybody, come on. No, it's coming this way. It's going upwards, right? Okay? So I'm going from the left, so it's going to be positive infinity. What if it's from the right? X approaches 0 to the positive exponent. It's still positive, isn't it? Okay?
Wait.
What? We're approaching
No, I
from the
didn't.
right.
I just dropped out mine for a couple seconds. I catch that.
Okay, you with me?
I'm with you.
Okay. Suppose that they both approaching the same thing. Will my fingers ever meet? My fingers won't meet, however, they're both gravitating towards the same place, right? Let me ask you something.
That would be the open circle, right?
If I had this, and I said, find the limit of this function of f of x as x approaches 2, does f of 2 exist? No, it does not exist. However, the limit as x approaches 2 of that function, what is it? We'll say that it's 1. Will my fingers ever meet there?
No.
Is that okay? Will they meet?
Yeah.
They're gonna
Will
look at each
they
other in the
literally
face.
be put together?
They're gonna put.
No, but they're going to get annoyingly what? Close. So this limit, the limit as x approaches 0, is it going to get annoyingly close to what value?
Oh,
It'll get annoyingly close to 0.
We write that on the
You are?
AP exam. It gets extremely annoyingly close.
You can.
They won't judge us for that,
No. Oh, for the AP? They might a little.
but it's
They
still the right
might,
answer.
but it's still correct.
don't grade
Okay,
this.
because it is getting, so what does that mean? If it's getting annoyingly close,
There's a limit.
what's occurring? There's an asymptote. What kind? Vertical or horizontal?
Vertical,
That means there's a vertical asymptote, a VA, at, Amber, what is it again? If it's the y-axis, it's x equals who? 0. Okay? It just means that there is an asymptote there.
the AP thing, even if